Hello everyone, welcome back to my channel. Hi, I'm Mathematic. Today we have a very interesting equation x squared minus x cubed equal to 36. And here's maybe the main question. Did you study well at school? You can easily pause the video and write your answer down into the comment section, write your solution down into the comment section, and in a few minutes we will check our answer. So it will be really interesting. So here's our equation x squared minus x cubed equal to 36. So how can we solve it? First of all, let's write this 36 on the left side. So as a result, we can easily write it as x squared minus x cubed minus 36 and equal to 0. So our first step, we just bring this from our left side, from our right side to left side. So our equation looks like that: x squared minus x cubed and minus 36 equal to 0. Right now, instead of this 36, let's write 27 plus 9. All right, so let's write it like that. So we have x squared minus x cubed minus, instead of this 36, we're gonna write 27 and plus 9. So I really hope you understand this step, equal to 0. Right now, let's open our parentheses. As a result, we will have like x squared minus x cubed minus 27, and as a result, we will have minus 9, because we open our parentheses, minus 9. And why I write this 36 as 27 plus 9? Because 27 is really great value, it's really great number. 27 equal to 3 cubed. And 9 equal to 3 square. So according to this substitution, looks like that. Yeah, we can easily group with this square with this square, and this cube with this cube. So let's see what will happen. So as a result, we have x squared minus x cubed. Yeah, we have minus x cubed minus 27. We're gonna write 3 cubed, and instead of this 9, we're gonna write minus 3 square equal to 0. Okay, so I really hope you understand it. Right now, we have x squared, we have 3 square, we have x cubed, yeah, we have right here x cubed, and we have 3 cubed. So right now, let's group both of these elements, and let's see what will happen. First of all, let's group our squares. So x squared minus 3 square in the first parentheses. Yeah, so we have x squared minus 3 square in the first parentheses, and we have minus, in another parenthesis, we will have x cubed minus 3 cubed, but we are talking about parentheses and a negative sign before, so we are talking about x cubed plus 3 cubed, all right, plus 3 cubed. So right now, as you can see, we grouped it. When we open parentheses, we have absolutely the same expression as in the beginning. All right, what are we going to do next? Right now, this is our difference of squares. So first of all, our first formula, a squared minus b squared, this is our difference of squares. So we have a minus b times a plus b. All right, this is our first formula, and we're gonna apply this formula right here, difference of squares. Right here we have the next formula, we have the sum of two cubes. This is also like a great basic formula. We have a cubed plus b cubed equal to a plus b, yeah, a plus b, and in another parenthesis we have a square minus ab, yeah, minus ab, and plus b square, and we're gonna apply this formula according to these parentheses. Okay, right here difference of squares, our school identity, and over here a sum of two cubes. So right now let's apply our both formulas. Let's start from this left side. Okay, first of all, a minus b, a plus b, so we have x plus 3 or x minus 3, doesn't matter, x plus 3 times x minus 3, and the next thing we have minus and these parentheses. All right, so we are talking about x plus 3 and times x squared minus 3x and plus 9 equal to 0. All right, so as you can see, we could write our expression according to these both formulas. Okay, what are we going to do next? X plus 3 we have right here, and we have x plus 3 right here, so we can easily factor these x plus 3. So as a result, we have x plus 3, and inside parentheses we will have this one, x minus 3, minus this expression, of course, inside parentheses, x squared minus 3x and plus 9. All right, equal to 0. Right now, let's simplify a little bit our second parenthesis. So as a result, we have x plus 3, and inside another parenthesis, we have x minus 3 minus x squared plus 3x and minus 9. And right now, we're going to simplify it. As a result, we have minus x squared, right? So we have the same beginning, x plus 3, we have minus x squared. The next thing, we have x plus 3x, so plus 4x, and we have minus 3 minus 9 equal to minus minus 12 equal to 0. And right now the most tricky moment, because right here we have product of two parentheses, and a product of two parentheses equal to 0 when the first parenthesis is equal to 0, so x plus 3 is equal to 0, or the second parenthesis equal to 0, minus x squared plus 4x and minus 12 equal to 0. All right, so from here x first is equal to minus 3. It looks like our first root. We're going to check it a little bit later, but right now let's solve this second quadratic equation, because maybe we'll have more roots, because according to a fundamental theorem of algebra, we have the third power. So it means that we have at least 3 roots. We don't know how many real numbers, how many complex number roots, but we will have at least 3 roots. Right now, multiplying by minus 1 or division, because we need to have positive right here. So we have x squared minus 4x and plus 12 equal to 0. Right now, let's find our discriminant real quick. So from here, we can easily find discriminant, or we can easily plug in this instantly in our x second and third formula. Everyone know about this formula, minus b plus minus square root of b squared minus 4ac and all over 2a. All right, so equal to, and right now let's see what will happen. Minus b, we have minus 4, so minus 4 plus minus square root of discriminant b squared minus 4ac. So we have minus 4 squared minus 4 times 1 and times 12. And we divide all of the stuff by 2 times 1. Let's simplify this. Let's see what will happen. So we have minus 4, we have 4 plus minus square root of, we have 16, minus 4 squared, we have 16 minus 4 times 1 times 12 equal to 48. And we divide all of the stuff by 2 equal to, we have 4 plus minus, we have square root of 16 minus 48 equal to minus 32, and we divide all of the stuff by 2. Right now let's simplify this a little bit, because this square root of minus 32, okay, it tells us that this is our complex roots, because discriminant cannot be negative in terms of real numbers. But let's simplify that. We will have 4 plus minus, this square root of minus 32 we can write as square root of 16 times 2 and times minus 1, all right? And in terms of like basic property, we can easily split it. So we can easily write it as 4 plus minus square root of 16 times square root of 2 times square root of minus 1. This is basic property in terms of like square roots. Okay, we can easily write it when we have product, of course. When we have addition, it not works like that. So right now, this square root of 16 equal to 4 and square root of minus 1 equal to I. These are a complex unit, so we have 4 plus minus 4 times square root of 2 and times I, and we divide all of the stuff by 2. Right now we can easily divide this numerator by 2. Okay, we can easily write it as 4 over 2 plus minus 4 square root of 2i over 2. We can easily divide it. When we add it, we will have absolutely the same thing, because these are a common denominator, right? So as a result, we have 4 over 2 equal to 2 plus minus. Right here we can easily cancel this, so we have 2 square root of 2 times 2 square root of 2 times I. All right, so we have 2 plus minus 2 square root of 2 times I. And this looks like this is our answer to this question. This is our looks like answer. Right now let's write our final answer to this question, because don't forget that we had x first, x second, and x third. So our final answer, we have x first equal to minus 3, x second equal to, let's go with the positive, so 2 plus 2 square root of 2i, and we have x third equal to 2 minus 2 square root of 2 times I. We have 3 roots to our question. X first and second, x third. X first, this is our real number root. X second and third, this is our complex path of solution. And of course, you can easily see this. These roots, because to be honest, a lot of students might be saying, okay, x first equal to minus 3, because we can easily find this root real quick without like a solution with the inspection method. So x squared minus x cubed equal to 36. And to be honest, a lot of students might be thinking, maybe like 80% of students might be saying, okay, x first equal to minus 3, then because we will have minus 3 square minus 3 cube equal to 36. So as a result, we have 9 plus 27 equal to 36. So a lot of students solve this question like that. They solve this question by inspection method. They say that the correct answer is -3. Yeah, this is absolutely great. But to be honest, you need to know about complex roots, because in your head you can't solve this question like that, in a few seconds, like inspection method. Yeah, you need to know about basic math skills, basic math steps. Yeah, and then you can easily find these complex solution. So x first and second and x third, forget about this inspection method. You can easily check this root by inspection method, but when you have equation, cubic equation, fourth power equation, you need to know that in terms of fundamental theorem of algebra right here, when we have 3 of the highest power, we need to know that in terms of fundamental theorem of algebra, we'll have like 3 roots. We don't know, at least, like, we don't know how many real numbers, how many complex numbers, but at least we will have 3 roots, and as you can see, we found all of these roots. So this is my explanation to this question. I really hope you understand it. I really hope you learned something new. It helps me a lot. It inspires me a lot to make new content every day. So I want to say thank you everyone for your support. Wish you all the best in your life, and see you in the next videos.